Hey guys, welcome back. Today we're going to talk about water. Water is a solvent. A solvent is an agent that dissolves other substances, and these substances are given the technical term solute and are dissolved in the solvent. So basically, if we get water, which is the solvent, and mix it with, let's say, salt, which is the solute, we get a solution. What we've gone over so far in the previous videos should make this a breeze. Water is a great solvent. It's made up of an oxygen covalently bonded to two hydrogen atoms in a polar fashion, meaning the electronegativities or pulling force on oxygen is much higher than that of either of the two hydrogen. A water molecule also has a bent shape, as I detailed in the previous video. What we haven't really touched on too much is the partial charges, these delta negatives and delta positives that exist as a result of the polar covalent bonds. Since oxygen was taking up more of the shared electrons for itself, we'll consider it partially negative, and as a result leaves the other two hydrogens partially positive. They're positive because their very own electrons were swaying further away from them. These differences in charges are really important because they allow two whole water molecules to interact together as well. Let me explain. As stated once before, opposites attract. And so the partially negative charges on the oxygen will tend to attract the partially positive charges on the hydrogen of another water molecule. This partially charged interaction is known as a hydrogen bond. Hydrogen bonds are just another way to describe what happens when a slightly positive hydrogen flirts with a slightly negative atom. Let's explain the difference between covalent bonds and hydrogen bonds. Covalent bonds deal with the sharing of electrons, while hydrogen bonds have hydrogen atoms bound to another atom. And this is based on its partially charged opposites attract self in the molecule. Like how a slightly negative oxygen is attracted to a slightly positive hydrogen. Realistically though, hydrogen bonds can form on many different substances like sugar and salt, and plenty more. The solutes that are able to dissolve into the solvent water is described as hydrophilic, meaning that they are water-loving. To give you an example of what's really happening, keep in mind that water is polar, meaning that it has different charges on different sides of itself. One side of the water is partially positive, while another side is partially negative. In this case, the oxygen is slightly negative and the hydrogen is slightly positive. If you'd like to learn more as to why, I left a link below in the description on a video that explains the reasoning why. Check it out. But if you'd rather get the short version as to why, it's due to electronegativity that creates these partial charges. As you place two water molecules together, positive charges on the hydrogen performs a hydrogen bond to the slightly negative charge on the oxygen. If you add another water molecule, you can see that it too follows the same behavior. Now just imagine millions of these molecules bonding together with their millions of hydrogens to their millions of oxygens, and then what you get is this aqueous liquid that you're most surely familiar with. Now these hydrogen bonds are relatively weak when you compare them to ionic bonds and even covalent bonds, and this is a good thing. In fact, all that was explained so far, the shape, the size, the polarity, specifically about water, makes it an excellent solvent. So what exactly happens when a block of salt is dropped into a cup of water? Here's how it'll look. Sodium and chloride ions have a pretty tight bond, an ionic bond. But that begins to loosen up due to the millions of more water molecules trying to pull them apart. Remember that all this is due to the charges. A group of water molecules will gang up on one of the salt's positively charged sodium ions by using a combination of their negatively charged oxygens. This results in several water molecules occupying a single sodium atom. The same occurs with a chloride ion. The hydrogens from the water molecules work together to pull this chloride once again. You'll see that it takes several water molecules to occupy a chloride ion. Awesome. It all makes sense, right? I think in the next video, we'll dive deeper into the behavior and characteristics of water. Again, thank you for watching. I hope you learned something today, If you appreciate these videos, I normally upload one every week on Sundays. Thumbs up if you like the video, thumbs down if you don't. If you'd like to get notifications about the next video, please subscribe to the channel and share it with your study buddies. See you next time. Peace.